So what we're looking at today, guys, the last part of chapter 2 is absolute value inequalities. So the last thing we're looking at today is absolute value inequalities. So we'll go on and close those Chromebooks, because this here is going to be key, because there's, like the compound inequalities we did last Thursday, Friday, it was kind of more easy to see, or easier to see which one was an and which one was an or. Because if it's an or, it really just said or. We had two statements. If it's an and statement, the variable was in the middle, and we solved either side. Yes, or it told us it was an and statement. The absolute value doesn't directly tell us if it's an and or statement. It kind of will, but we need to know what to look for. So the inequality x is less than 2 means the distance between x and 0 is less than 2. And the way that I kind of remember and keep this straight is less than. Less than. And I'd write that down in your notes. Because we have an absolute value is less than. It's an and statement. When we talk about less than, or equal to, it's an and statement. And this just mainly works with absolute values. And we also have great or than, great or. Whatever's inside the absolute value is great or then we have this. So we have less than and great or. Less than and great or then. And if you're thinking that's the incorrect way to spell then and greater, I know. Because it's greater, it's supposed to be ER technically. But when we talk about absolute values, great or than is our or statements. Great or than is our or statement. Less than is our and. And these here are going to be ways for us to tell, are we talking about an and statement or an or statement? Because with absolute values, they are compound inequalities. They are compound inequalities, and they're either going to be an and statement or an or statement. They're going to be one or the other. Solving absolute values, you have this here. So if the absolute value of ax plus b is less than c, it's going to be greater than negative c and less than negative c. So we write the first one, we drop the absolute values and leave it. But when we change the sign for c, we flip it. Now this is kind of going back to absolute value. 6x plus 7 is greater than 6. Now when we talked about, let me do equals. So I just pay attention to this here. Because we've done these before, yes? Because the absolute value can be, what's inside the absolute value can be positive or negative. So we set it 1 equal to this way, and 1 equal to the negative. We have the positive and negative on one side, yes? So when we look at not equals anymore, when we look at greater than or less than, greater than or equal to these inequalities, we're going to rewrite one of them by just dropping the absolute values. Now the negative, since I changed the sign of 1, I have to flip the inequality sign. So the negative case, the negative 1 case, we have to change that sign with it. And that's where they get these here and these here. So when we have that, we have to switch it. And we'll get more into it. Let's actually, when we solve it, it'll make sense. So when we solve this here, we're going to have several steps. Step number one. Is it an and statement or and or statement? We want to figure out, are we talking about an and statement or an or statement? And it is less than. Less than. So this one here is an and statement. Now we need to write the two cases. So our first case is just dropping it. We'd have x plus 7 is less than or equal to 2. And x plus 7, we have to flip the sign and change the number. We have to flip the sign and change the number with our two cases. And our last step, step 3, is going to be to solve both and then graph, because they're going to want us to graph these. Any questions on any of these so far? Cases, C-A-S-E-S. Almost. So any questions on this so far? Any questions on what we've done so far? So now we need to solve it because we have our two cases, yes? So looking at the one on the left, what do I need to do to get the variable by itself? Minus 7 from both sides. Is 7, positive 7 minus 7 would give us? Cancel out, give us 0. So x is less than or equal to negative 5. I'm going to go on and keep writing and. I'm going to put and again between our two numbers when we get them solved. Just to remind myself what statement I'm talking about. I'm talking about an and statement. We're going to do the same thing here. We're going to subtract 7 from both sides. Yes? Does these cancel? Negative 2 minus negative 7 would give us negative 9. So x is less than or equal to negative 5, and x is greater than or equal to negative 9. Yes? How many of y'all have a little bit of trouble rewriting this into one statement? A little bit? That's fine. I mean, we can do it to rewrite this in one statement because we need x in the middle. Yes? Now, when we write it as one statement, the arrows normally point to the left. So what number is x greater than? X is greater than or equal to negative 9. X is less than negative 5. Huh? No, they're good because here x is less than negative 5, yes? So that works. Here x is greater than or equal to negative 9. So it is, but we flipped it, so it works. Does that make sense? No? We get it? Kinda. Because I could rewrite this one here as negative 9 is less than or equal to x, yes? Flipped it. And that's what we have here. Because for these and statement, x should be in the middle. If it is a true statement, x is in the middle. Any questions on this here, how we got to this? Now we need to graph it, yes? X is in the middle. So we would shade in the middle, yes? And are the circles opened or closed? Closed, because it is equal to. Questions on this here? Okay. Solve and graph each solution if possible. The absolute value of x minus 11 is less than 0. Is less than 0. So this here, so our first step was what? Determine if it's an and or. Is this an and statement or an or statement? And, because it's less than. So this is in. So that one there, we can put and. I normally would put and. So in the center of the page, I'd write it like that. I wouldn't put it, I'd put it up closer to like where we're at. Because I'm going to put my stuff, the two cases on either side. So I'm going to put it up towards the top so that I have space, because it is an and statement. Now our second step was to write the two cases. Our positive case and our negative case. So the positive case would be 8x minus 11 is less than 0. The other case would be what? 8x minus 11 is what? Greater than 0, because we'll have the two cases. One's going to be less than, the other is going to be greater than, because normally we would have a negative, but 0 is not positive or negative. So we have these two cases here. So any questions on how we got this set up? Now we need to solve. So solving this one here for x, our first thing we need to do is to what? We need to get x by itself, or 8x by itself. So we get 8x is less than 11. Then what do? We would divide both sides by. And we get x is less than 11/8. And most likely we're going to finish up here. Now we need to solve the other side. Well, luckily for us, most of these here, when we solve them, the steps are going to be the same. So what did we do first? We added 11. Well, we'd actually add 11 here, because negative 11 and positive 11 would cancel, leaving us with 8x is greater than 11. And then what would we do next? We would divide both sides by 8 and get x is greater than 11/8. Did we actually get the same number on both of these here? Okay. Let's see how this works. Let's look at the graph and see how this works. Because on both of these we have 11/8, yes? So I'm going to signify this one as purple. So at 11/8, do we have an open circle or closed circle? So I'm going to draw this above the line first. Open, and it would shade to the left because it's less than, yes? So we have it going this way. Let's call this one red. So at 11/8, this is, it's open and it goes to the right, yes? What do these, so the purple one and the red one, what do they have in common? So neither one of them includes 11/8, correct? Well, no, because it's open, yes? Is there anything else that those two share? Besides, because they don't share 11/8 because it's not equal to, correct? So is there anything they share? No. So this here is because here there's not going to be a value where that it's going to make it less than 0. Because if it's less than 0, well, what is less than 0? Negative numbers, yes? Can I ever get a negative number come out in absolute value? No, an absolute value is always a non-negative number. So for this one here, the only one that would work for 11/8, that would give me 0. But since it's not equal to, it doesn't work. Questions on this here? So this one here is kind of a special case. Let's look at this one here. So now our first main step is to determine whether it's an and statement or an or statement. So we look at this here. This is less than, yes? So this here is another and statement. They're not all and statements. But it works out that the ones we've had so far are. So this one here is an and statement. And what are our two statements going to be? We're going to have what? X plus 3 is less than or equal to 2. And our other one would be x plus 3 is greater than or equal to negative 2. Any questions on any of this here so far? So let's look at the left one first. X plus 3 is less than or equal to 2. What do I need to do to get the value of x by itself? I need to minus 3 from both sides. Because 3 minus 3 is 0, they cancel out. 2 minus 3 is negative 1. And we got x by itself. X is less than or equal to negative 1. Now let's look at the other one. X plus 3 is greater than or equal to negative 2. So our first step would be 2 minus 3 from both sides. Because again, positive 3 minus 3 is 0. And leaves us with x is greater than or equal to negative 5. Because negative 2 minus 3 is negative 5. Because it's an and statement, x is in the middle. X should be in the middle. X is less than what? And x is bigger than? As if this works, the smaller number should be on the left, the bigger number should be on the right. Yes. Would the circles be opened or closed? They're both closed because it's equal to. And we shade in the middle because x is in the middle. When x is in the middle, we shade in the middle. Any questions on this here? We good with this here? That's it. 3c minus 5 is less than negative 2. It is less than negative 2. So this here, would it be an and or an or statement? And, because it's less than. It's less than. So let's look at our two statements. So the first one would be, we're going to drop the absolute value. So we get 3c minus 5 is less than negative 2. The other statement would be 3c minus 5 is what? Not less than, it would be greater than 2. So what would be our first step here? We need to add 5 to both sides, because to get the variable by itself, we need to add 5, because it's going to be easier to add 5 first. So when we add 5, these two cancel out, leaving us with 3c. Then 3, because negative 2 plus 5 would give me 3. And if you have troubles dealing with negatives and positives, just put it in the calculator. The calculator will tell us. And last but not least, we need to divide both sides by 3. And we get c is less than 1. So on the other side, we're going to add 5 to both sides, because hopefully you notice like we're doing the same two kind of steps on each one. However many steps we do on one, we got to do on the other, because those cancel. Which gives me 3c is greater than 2 plus 5 is 7. Yes? And then what do? We divide both sides by 3. And we get c is greater than 7/3. Now, if you need to turn that into a decimal to see how it works or how it looks, that's fine. You can do that. But is 7/3 bigger or smaller than 1? Because what is 7 divided by 3? What is 7 divided by 3? 2.3 repeated. So it's bigger than 1, yes? For it to be 1, well, 3 over 3 is 1, yes? So if the numerator is bigger, then the denominator is normally greater than 1. So okay. So it's not equal to, so we don't have the equal to sign. So we can write this as one statement. So what's the smaller number? 1. So x is bigger than 1, yes? Or, well, here it's not x, it's c, yes? Is that what we have here? No. It's this way, isn't it? And then c is... That's not right either, isn't it? That looks weird, doesn't it? Okay. That's kind of weird. Let's look at this on a number line. So this here, C is less than 1. So at 1, we're going this direction here, yes? And this one is going this way, yes? Now, what did we say this was? We said this was an... Is there anything in common? No, right? There's nothing in common here. So this here is a... Because the only way this could be an OR statement is if this was greater. Because if it said the absolute value is greater than -2, it would work. Okay. I'm going to erase all that there. Let's look back at this. What did we say comes out of the absolute value? A number that is always greater than or equal to what? 0, yes? Because the absolute value is always a non-negative number, either 0 or a positive number. So will there ever be a case that it's less than a -2? No, for it to be less than -2, it has to be a smaller or bigger negative number, yes? But will the absolute values ever give me a negative number? Unless there's one outside of it. So if we get the absolute values by themselves, there's nothing being multiplied, nothing being added or subtracted, and it's telling me that it's less than a negative number, this here is no solution. But we have to move everything first. We have to move everything first. Because if there had been -2 out front, we have to divide both sides by -2. So we have to move everything first. And once we move everything and it's still negative, then it's no solution. So even if I added 6 out front, it would still be no solution, because does that change the sign of the negative? Well, no. We'd almost need this to be what? -6. If it was -6 multiplied, then it would. But here, just 6 wouldn't. So this here is no solution. Let's look at one more of these. I think we have a few more ands, and then it goes over to or. Are we good with these here so far? Yes? This here would be no solution. Let's look at one of these here. We'll look at 1 or 2 of these here, and then we'll call it for today, and then we'll look at this again tomorrow. So the first thing we need to determine is it an and statement or an or statement? Or, it's great or than. So this here is an or. Because we have great or than 5. So the first case, we drop the absolute values and keep the sign the same. So we're saying C minus 1 is greater than or equal to 5. And then our other case, C minus 1 is what? Or equal to. Because one case we leave it the same, we just drop the absolute value. The other, we flip the inequality and change the sign of the number. So looking at this first one here, what do we need to do to get C by itself? We need to almost add 1. Since 1 is negative, we have C minus 1. We do the opposite of subtraction, which is addition, so we would add 1. So -1 plus 1 would give me 0, and I get C by itself. Is greater than or equal to 6. So let's look at the other one. Here we would add 1 also. This negative 1 plus 1 would and it would be negative. Thank you. Have a good one. So this here is an OR statement. So on OR statements, we really include both. We don't have to worry about overlap. Now, because it's equal to, we would fill these in, yes? Now, let's look at here. C is greater than or equal to 6. So at 6, do we shade to the right or to the left? We shade to the right. Then over here, we have C is less than or equal to negative 4. So at negative 4, do we shade to the left or to the right? To the left. And that's it. That's it for this here. Questions on these here? This will be the last one we do. And this one's actually going to be pretty simple. Now, when we talked about AND statements, so if, because remember we talked about this kind of setup with AND where we had a negative number, yes? And we said the absolute values will always give me what? A 0 or a positive number, yes? So 0 and positive. Wait a minute. Is that going to be greater than negative 2? Will there be any case where I could plug a number into this and it'd be less than negative 2? No, right? Because it's always going to be positive or 0, something bigger than it. This is everything. This would be, and you'd fill the whole number line in. This would be all real solution because it's any number. All of them work. It's all real solutions. This here would be all real solutions, and you'd color the whole number line in. Did y'all get this written down? Okay. So I'm going to have y'all watch this, 10 minus m. I'm going to go on and work this out. Because here, our first thing would be to subtract 10 from both sides, yes? And that would tell me that negative m is greater than or equal to negative 12. Well, I would divide by negative 1. And whenever we multiply or divide by a negative, we have to switch the sign. So we get m is less than or equal to 12. That's fine. Over here, I'm going to subtract 10 from both sides. And I get negative m is less than or equal to negative 8. Because 2 minus 10 is going to be negative 8. And kind of like we did with the other one, I've got to divide both sides by negative 1 so that I get m positive. This here will give me that m is greater than or equal to 8. So I'm going to graph it. Negative 8. Not negative 8. 8 and 12. So at 8, it is included, yes? So I would shade it in. And we're shading to the left or to the right? To the right, because it's bigger, yes? I have all this here. Now at 12, we did include it. because it's equal to, and we shade to the, that is everything. So if you didn't notice that it worked out that it's always going to be positive, so it's always going to be greater than that negative number, even when we worked it out, it still worked out to be all real numbers. Okay? So with or, we always include both statements. Yes? Even if in an or statement, it won't work out with absolute values, because it'll always be, because we're never going to have a statement like this here where one is equal to and the other is not. But in an or statement, if we had this set up, it's still all real solutions. Because for here, is m, if m was 8, would this be true? Is 8 greater than 8? No, right? That's not true. That'd be false. But here, is 8 less than or equal to 12? Yes, 8 is less than or equal to 12, yes? So with this here, even though one of them wouldn't be included if we had this set up, because an or statement only needs one of the statements to be true. It doesn't need both. So even though this wouldn't be less than, this isn't for this example, even if it was set up this way, it would still be all real, because it makes one of them true. But we don't have that. We have it that they're both here. And that's where we're going to stop for today. And we'll pick this up tomorrow. We'll pick this up tomorrow. We're going to finish the chapter tomorrow. Tomorrow will be the last day of chapter 2, which means tomorrow's the last day of chapter 2.